All right, Chem, today we're going to learn a little bit more about bonding. If you remember, yesterday we separated our compounds into ionic and covalent. And today we're going to take those covalent bonds and separate them into polar and nonpolar. The covalent that we built yesterday, which was oxygen, and what else did we do? Fluorine. Those are nonpolar covalent. Today we're going to learn about polar covalent. Remember the first day of the unit when we separated things based on their differences in electronegativity? When you have electronegativity greater than 0.5 or greater, it's going to be classified as a polar covalent bond. So we know that covalent means that we're sharing a pair of bonding electrons. So this shared pair or bonding pair between two fluorines is going to represent a totally nonpolar bond. So fluorine has an electronegativity of 4.0, but each is 4.0. Therefore, the difference between them is 0. So each of them pulls on the electrons with equal force, and the bonding pair is shared equally. But if we have two different atoms that share a bond, one's going to pull more strongly on the bonding electrons. So here's an example. You can look at the periodic table of the elements. Remember what we learned about electronegativity. Based on what we learned about electronegativity, which atom has a greater electronegativity, hydrogen or chlorine? Anybody know? Do you know, Jake? It is chlorine. The reason we know it's chlorine, because if you look, fluorine is the most electronegative. So the closer you are to fluorine, the more electronegative you are. Obviously, after we exclude the noble gases. The second most electronegative element on the periodic table of the elements is oxygen, then chlorine, nitrogen, sulfur, bromine, so on and so forth. So the electrons in this pair will be closer to chlorine because chlorine is better at pulling electrons in a shared bond towards itself. Because these bonding electrons carry a negative charge, the closer they get to the chlorine atom, the more negative chlorine gets. The farther they get away from hydrogen, the more positive hydrogen gets. But the charge is only partial. Hydrogen hasn't lost the electrons as in the formation of an ion or an ionic compound. So there's an unequal sharing of electrons. So we're not going to use full partial positives and negatives. We're going to use what's called partial charges or partial positives and negatives. And this is how we draw them. Notice that letter is written kind of like an S, but you keep the bottom going all the way around because you're going to have to draw partial positives and partial negatives. The only truly nonpolar substances or compounds consist of diatomic elements or molecules with symmetry. A polar bond is a bond where electrons are shared unequally, which will lead to regions of partial negative and partial positive. This is called a dipole. So molecules are said to have a dipole when they have partial negatives and partial positives. The degree of sharing is determined by the electronegativity difference of the two atoms. So these guys both have an electronegativity of 4.0, so the difference is 0, so they share equally. Non-polar covalent molecules do not get any positives or negatives. Two atoms with a small difference will share unequally, resulting in a positive partial charge. So the difference between chlorine and hydrogen is 0.9, makes them polar covalent. You will use partial positives and partial negatives when it's a polar covalent molecule. And just to remind ourselves, atoms with large differences in electronegativity will result in a loss of an electron with full charges. These are going to be our ionic compounds. For our purposes, if you see a metal in that first position, we can call it ionic. And this is an electronegativity difference of 3.2, which puts it in the ionic range. So we will use full pluses and minuses, and we will show a transfer of the electrons.